Hello everybody. Sorry for being absent today / last time, but hopefully this will help in case you guys have any questions. And hopefully you can hear me okay because I am filming this in IE. So the first section, you have to evaluate all of these. Okay, remember anything raised to the 0 power is just 1. So okay, so anything to the 0 power we said is 1. So 3 to the 0 power, 1. Negative 2 to the 0 power, 1. Negative powers, remember, you put them over 1 and then you flip them. So this would be 1 over 3 to the 4th power. And then we're going to use our calculator. And 3 to the 4th power is 81. So this is 1 over 81. Then, sorry for that, same deal. The negative exponent is what gets turned positive when you flip it. So we would have negative 4 still, but now it's to the positive 3. And I'm going to put parentheses around it when I plug it into my calculator. And we do get negative 64, and that'll go out front of your fraction. Then, same deal, okay? You could end up moving this to the bottom right away, and 5 to the 0 is just going to turn into 1. We wouldn't move that one. That one could stay there, but we would end up with 1 over 5 to the 0, 2 to the negative 3. And then, sorry, that would turn positive, actually. That would be 2 to the 3rd now. So then we would have 1 times 2 to the 3, which is 8, or 1 over 8. This one, they're both negative, so they can just switch spots. 2 to the 3rd, negative 3 squared. Now, usually when there's no parentheses on that, it means they want it to stay negative. Usually that's what it means. If they wanted it to turn positive, then they would have put parentheses around it. So that would be 8 over a negative 9, so negative 8 over 9. Again, this would give me 9, but this would give me negative 9. Okay? A little bit different thing there. Here, the 4 to the negative 1 is going to go to the bottom because it's got a negative exponent, and there's no negative exponent on the bottom, so we just leave a 1 there. So we'll have negative 7 to the 0, and then 4 to the 1 now. So then we'll have negative 7 to the 0 is just going to be 1, but there's a negative there, so we would go 7 to the 0, which is 1, and then keep it a negative. So there's no parentheses. If there were parentheses, then the whole thing would just be 1, and you wouldn't have a negative. We'll have negative 1, and then the 4, so negative 1/4. And then this one, now there's parentheses, so this is just like 3 to the negative 1 over 1. And then we're going to move it to the bottom, so 1 over 3. All right, keep on cruising to the bottom here. Z to the 0, boop, that's just 1. A to the negative 8, that is 1 over A to the 8th power. These, you got to kind of go piece by piece. The only thing we can do is change that to a 1. And that B, we're going to move to the bottom. 6 stays there. So technically it turned into a 1, and then B squared is going to move to the bottom. So we would have 6 over B squared. Okay, then right here, 14 is separate. This guy is going to go to the bottom, and this is going to turn into 1. So we got 14 times 1, and then M to the 4th is on the bottom. Okay, then keep on cruising. Both of these are going to go to the bottom. So then a 1 is going to be left on top because there's nothing left up there. So we'll have 3 squared r to the third s to the 0. So 1 over 9 r to the third, and then s to the 0 is just 1. So 1 over 9 r to the third. Then we've got some more of our rules here. This will be the last one I do on this page. And then I will just, yeah, it's a lot to, whatever, we'll keep on cruising. Okay, so 2 to the third is just 8. That stays there. A to the negative 3 is going to go to the bottom. And then on the bottom, we've got these two, which are going to go to the top. So we'll have 8 to the first and b to the fifth. Because remember, when they move, they turn positive. And then on the bottom, we have that a to the third and c to the 0. So 8 to the first is just 8. So 8 times 8 is 64. And then on the bottom, we have a to the third because c to the 0 is just 1. Then remember, our quotient rule is real helpful here. You guys could totally evaluate it in your calculator. This is a great one for that. But this is also 3 to the 5 minus 3, which is 3 squared, which is 9. That's our quotient rule. Another quotient rule here, we'd have negative 2 to the 7 minus 5, which is negative 2 squared, which is 4. Here we have our product rule there. We're going to have the same base, and then we add those exponents. 3 plus 3 is 6. So negative 5, we're going to get a positive there, right? Is 15,625. Then power to a power rule, we're going to multiply. Same deal here, power to a power rule, we're going to multiply 1 over a to the 8th. Here, we're going to add on the top, c to the 7th, and then we're going to subtract c to the 1st, which is just c. Here, we got to distribute that power. And then negative 4 to the 4th. Remember, it had parentheses around it. I just kind of continued it. Is 256. Same deal. Oh, this one, I'm actually going to, excuse me, turn into a fraction. Excuse me, turn it positive. So now I'll have 1 over 3 to the 3rd, f to the 3rd. 3 to the 3rd, I believe, is 27. Yep, 27. Okay, this one's going to switch locations, and then I'm going to distribute. Oops. X over 4 to the 3rd. So we get x to the 3rd over 4 to the 3rd, which is 64. And then this last one, a rectangular prism has a length, width, and height there. Which expression represents the volume? So volume is equal to length times width times height. So we would go x times x over 2 times x over 3. Now we've got a lot of kind of weird stuff happening here, right? So multiplication is commutative, remember. There's a few options here, right? Multiplication is commutative, so I would go x to the 3rd on the top, because when you're multiplying with these exponents, you're adding them. And then 2 times 3 is 6. And then if I wanted to bring that 6 to the top, that would turn into a 6 to the negative 1. So A works. Oh, it says select all of them. B does not work because that would mean you would have to have a negative exponent. C works because if I distribute that power, I would get the same thing. D also works because if I multiplied all of the numerators, that's x to the third, then I'm left over with this 1/2 and 1/3. And another way to write 1/2, you guessed it, is 2 to the negative 1 power. So D works too. Okay, in this one, they want me to find the root. This is all calculatory, friends. So I'm not going to go through this one. This one you could just plug in your calculator. Up here, remember the root is your n. So this would be like the square root, and you really don't need to put a 2 there for square root. So you would write positive or negative 8. Don't forget there's 2 answers there if it's a positive, if it's an even root. Okay, this one involves rewriting. Okay, so rational exponent form. Remember, whatever the root is, that goes in the denominator. So 4 to the 3/5. Whatever the root is the denominator. Negative 8 to the 2/3. 15 to the 7/4. Okay. Then, whatever that root is, the denominator is the root. So 5th root of negative 3 squared. And it really doesn't matter if you have it like that or like this, whatever. I mean, it's fine. It means the same thing. Square root of 6 to the 3rd. 4th root of 12 to the 3rd. Then it says evaluate. This is all in your calculator, guys, so I'm not going to go through that just because of time. Okay, this is the radius of a sphere is given, but just make sure up here that you're typing it in correctly. And I'll put the answers up there in the key. Okay, this is the radius of a sphere equation where A is the surface area. So they're telling us the surface area is 1493. And they want me to find the radius. So I'm going to plug it in my calculator just like that. And I'm going to use that fraction key. I'm using the fraction key, guys. It makes it so much easier. So we get a radius of about 10.9 meters. It does say to round it to the nearest tenth. Okay, last page. So we kind of went through this one real briefly. And then I wasn't here, so I do understand if there are questions. So remember, if your exponential function, right, so we have y equals ab to the x. If this b value is greater than 1, then it's growth. If your b value is between 1 and 0, so that means it's a fraction, but it's a fraction less than 1, then it's decay. A lot of people were getting confused because they thought things like 2, because it's got a decimal in there, it means it's exponential decay, but it's not because it's bigger than 1. So this one would be exponential decay because it is a fraction that is much smaller than 1. So when we graph it, we got to put our grid in there. And a lot of these graphs aren't going to be very detailed because they're very tiny. I'm just drawing all my grids. Okay, so that's exponential decay. Let's go ahead and make a chart for that. So we'll have x and y. We'll have some negative values and positives. Okay, So if I raise it to the 0 power, I'm automatically going to get 1. So that's kind of a given. If I raise it to that -1 power, I'm actually going to get 1/12 to the -1. And that's a negative exponent, so it's just going to flip it. 12 to the first, which is 12. This one's the same thing. This is going to flip it, and then I raise it to a power of 2. So I would have 12 times 2 is 24. And then this one will be that just 1/12, and this is that 1/24. So I'm going to go by 3, no, 4, 8, 12, nope. I'm just going to go by 12s, right? 12, 24, 36. And then 1, 2, 3, etc. Okay, so we're going to have -2, 24, -1, 12, 0, 1, 1. So it just gets smaller and smaller. Okay. Does not say anything about domain and range, so yay, we're good there. Okay, let's do the next one. Okay, I'm hopeful that this continued because I started this video in Flexi and kind of finished it now. So anyway, as you keep making these graphs, just be aware if it's greater, if it's a decimal, but it's greater than 1, that's still okay. That is exponential growth. And then you'll make the chart and then graph it. This one is going to be bigger than 1, and even though it's a fraction, so this is also growth. And this guy is less than 1, so this is decay. So that kind of makes growth and decay, but the different charts will be based off of what your chart shows. Okay? So you would plug it in and kind of get your graph from there, and you can check the review key after this video. In this next example, they give you the model, okay, and they want you to identify if it's growth or decay. So in this example, we got to kind of make it look like the growth or decay model first. So we would, well, we can kind of tell what happened. You know, the formula is where you have your starting number, and on the inside of the parentheses, you're either adding or subtracting. And the only way to get 1.99 by 1 is if you added 1. So this is definitely going to be exponential growth. And the percent increase or decrease in the number of bacteria, this is kind of wild, but this actually, if it's kind of spread apart like that, this would be a 99% increase, right? And then to estimate when the bacteria will be 1 million, you would just keep plugging stuff in to see when that'll happen. So go ahead and check the answer key. And you would plug stuff in for T. So T represents the number of hours. So T of 2 is 2 hours. So you would just plug in an exponent of 2. And then whichever one gets you closest to 1 million is the winner. But it says estimate, so it's okay to get kind of close. We aren't doing any recursive rules, so don't worry about that. And this bottom part here, this one is what I think is more challenging. You got to use your exponent rules to kind of split it apart. Okay? So this one, it looks like they're adding. And we know when they're adding with exponents, that is a product rule, right? When you're multiplying, that's when you're really adding there. So we would kind of change this around to... And it looks like... Sorry, I had to pause for a minute. It's very hard to do a video and do the math at the same time, apparently. But we would split that apart to be same base, right? When you add the exponents, they have the same base. So you're just kind of spreading that base apart. And then with exponents, whatever has your numbers there, you can just kind of combine them together. So I'm going to go okay, I kind of kept stopping, guys, because I was just doubting myself. But this bottom one, if you keep checking stuff by plugging a different time into there, you'll get kind of close to the 1 million mark. So I'm plugging in 3 right now, and I get 788.1. And then if you plug in 4, you get why are they saying 3 point? Oh, that's already in thousands. So, okay, thousands of thousands right there. So, yeah, you would just keep checking until you get really close. So this is actually, when that is in thousands. So 788,000 according to what that says. So this would be 1,568,000, which is 1,568,000, all that stuff. So they kind of narrowed it down and they got to about 3.35. So you just kind of guess and check with that one. With this guy at the bottom, you noticed you were adding, so that's definitely the quotient rule. So we use the same base and we just split apart the exponents. And then this and this we can throw in the calculator. And when you do that, you get 7.32 times. And then we keep this part because that part has the base and the exponent. Okay, so that would be our answer there. And then we can tell if it's exponential growth or decay. This one's going to be growth because it's bigger than 1. So if it looks like we added 1 plus some sort of a rate, that means it's growth. So this one's growth. So since it looks like we added, we can set that equal to, we can just kind of take off that 1 that we added to it, and that'll tell us our rate. So we have a 25% growth rate. Okay, let's do the next one. Next one, you can tell we multiplied those exponents. So that's the power to a power rule. Okay, so if we kind of like factor that out a little bit, and I'm just kind of matching it. Yeah, we're gonna, yep, so we can kind of shush out that. So it looks like we raised a power to power. We're going to take the variable and stick it on the outside for a second, because then that'll help us just get some kind of a rate in here. So 0.44 to the 7th power is 0.0032 to the t power, and that's like incredibly small, right? So that's definitely an exponential decay. And the model tells us that the inside of that, so this is the 1 minus the growth rate to the t, we're going to take that middle and we're going to set it equal to that part in the middle. 1 minus r equals 0.0032. And then we can solve for r to figure out our rate. So we get negative 0.9968. And then we divide by -1. So we get a rate of 0.9968, or 99.68% decay rate. Okay, so do the best you can on this, guys. Yeah, you can use your reviews to help, and then if this section is tricky for us when I grade it, we'll have kind of a review day of it. Thanks, guys.